Okay, for the last part of ELT today, which if you don't get time to do it today, go ahead and do it tomorrow, is graphing linear inequalities. So if you're in my 7th grade Algebra ELT, shout out to my 4A, we haven't done this yet. We're actually going to do this today, so this is going to be a good introduction for you all. So when I graph a linear inequality, I start the same way I start by graphing lines. I make sure it's in the correct slope, intercept form. Or also known as y equals mx plus b. Step 2 is I find my y-intercept, or b, plot that, find my slope, use that to make my other points, and then I'm going to decide, since this is an inequality, am I going to connect my points using a dashed line, a solid line, and then I'm going to decide which way to shade. The reason we have to do these extra steps is because inequalities are different than equations. Inequalities have many, many solutions. This inequality, y is less than or equal to negative 8/3 x minus 3, y can be anything less than or equal to this. So it is in slope-intercept form. My y-intercept is negative 3. I've already plotted that. My slope is negative 8/3. So I know the line's going to look like this. And since it's rise over run, I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. Oops. And over 3. I'm so sorry. This shouldn't be a point. That's why we don't do math and pen. And then if I want to go the other way, I would go down 8 over 3. Okay, so I have these points. And I'm about to connect them. Since y is less than or equal to this, I'm going to connect them using a solid line. And now, inequalities don't have just one answer, they have many. So any point on this line would be a solution, but also, since it's less than or equal to, any point below the line would also be a solution. So whenever I see this symbol, I'm going to shade below. So what this means is, well, x could be 0, negative 3. Or sorry, a point could be, a solution could be 0, comma, negative 3 because it's on the solid line. Another solution could be negative 2, negative 4 right here because it's in the shaded area. Now for number 2, same thing. Is it in slope-intercept form? Yes. Okay. Go on to find the y-intercept, which is negative 4. My slope is negative 2/5. Up 2 over 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4, 5. Now, this is the new part for inequalities. I have just a greater than sign. So y has to be greater than. I'm going to connect the point using a dashed line. Okay, now the question is where to shade. Well, y is greater than. Where are the greater numbers? Over here. So I'm going to shade everything above this line. Try number 3 with a partner. When you're done, get up and check the key. Or have your teacher go over it. Number 4 is a little bit different. X is greater than or equal to 4. So you might remember from the previous video where we had something where x equals a number, and that was an undefined slope. So when I have that, x is always 4. An undefined slope looks like this. Now, the reason I made a solid line is because x could be greater than or equal to 4. So if it's greater than or equal to, it's solid. Now I have to decide I'm going to shade above or shade below. Well, x is greater than or equal to 4. So if I shade below this way, well, x is 3, x is 2, x is 1. Is 1 greater than or equal to 4? No, so I'm going to shade over here, because if I shade over here, this is saying, oh, x can be 5. Is 5 greater than 4? Yeah, it works. X can be 6. Is 6 greater than 4? Yeah, it works.